Hello, I'm Dr. Millicent Thomas. In this video, I would like to explain about a continuous distribution. An example of a continuous distribution is a normal distribution. And let us see what is the 68, 95, 99.7 rule for a normal distribution. Since normal distribution is a continuous distribution, it is always described by a density curve. Density curves are curves drawn above a horizontal line such that the area under the curve is 1, which is the total probability. Normal distribution will have a density curve, looks like a bell-shaped curve. It is a bell-shaped curve as seen in this diagram. And the density curve has an equation f of x equals 1 by square root pi e raised to minus half x minus mu by sigma the whole squared, where mu is the mean and sigma is the standard deviation. Sigma is the standard deviation, and it is always denoted by n of mu sigma. So when we say a distribution n mu sigma, we know that it is normal with mean mu and standard deviation sigma. So when you have a normal curve, the mean of the distribution is the center. And how these values are spread is calculated using the standard deviation. So how the curve is distributed, that is, if you have a flattened curve, then the standard deviation is more because it is widely distributed. Whereas if it is clustered, if it is towards the mean, then the standard deviation, it doesn't have much standard deviation, so the standard deviation would be less. A normal curve is always a bell-shaped curve and it is symmetric. It is symmetric about the mean because mean is the center. Mean is the middle value and it divides the whole distribution into two halves. Since the area under the curve is always 1, here the total area under the bell-shaped curve must be 1. And it is always determined by its mean mu and standard deviation sigma. So we need two parameters, either mu or both mu and sigma. The 68, 95, 99.7 rule says that 68% of the data will fall between mu minus 1 sigma to mu plus 1 sigma within one standard deviation of the mean. 95% lie within 2 standard deviation of the mean, and 99.7 lies within 3 standard deviation of the mean. This is our 68, 95 and 99.7 rule, which is also known as the empirical formula. So when we divide this area, the center portion, that is within one standard deviation of the mean, between mu minus 1 sigma to mu plus 1 sigma, we have 68% of the data will lie. Within 2 standard deviations, we have 95%, and within 3 standard deviation, we have 99.7%. So since it is symmetrical, when we divide this whole area, 68, 95, 99.7 rule, this is what we will have. This is mu minus 1 sigma, mu plus 1 sigma with 68. So when you divide that into half, you'll have 34 on either side. Mu minus 2 sigma to mu plus 2 sigma, you have got 95%. So 95 when we divide by 2, it is 47.5. Already we have 34 in the center, so this area will be 13.5 and this will be 13.5. that is this area will be 13.5 and this area is going to be 13.5. Now since 95% of the data lie between -3 sigma to +3 sigma, we will have this shaded region to be this shaded region here to be 2.35. So when you add everything together, you'll have 99.7. Then the small portion here, this meager amount, will be half of 0.3 because 99.7 lies in the center between -3 sigma to +3 sigma. 100 minus 99.7 will be 0.3. Half of 0.3 is 0.15. So only that meager amount will lie on both ends of the scale, 0.15, 0.15. Let's make use of the 68, 95, 99.7 rule, what we have learned about the normal distribution, to find the answers for this question. This example is on the IQ test score. It says the IQ test score is approximately normal with mean 100 and standard deviation 50. So in a normal curve, the center is 100 and I can mark 3 points to the right, which gives me mu plus 1 sigma, mu plus 2 sigma, and mu plus 3 sigma. And to my left, I can find mu minus 1 sigma, mu minus 2 sigma, and mu minus 3 sigma. So it looks like between 55 to 145, 99.7% of the data will lie. Between 70 to 130, 95% will lie. And 85 to 115, 68% of the data will lie. The first question here is, what percentage of students will have scores above 100? 100 is the center. Above 100 is exactly half of the distribution. So 50% of the students will have scores above 100. What percentage of students will have above 145? 145 is nothing but 3 sigma, mu plus 3 sigma. So between mu and 3 sigma, I'll have half of 97.5. So the portion above 3 sigma will be 50 minus half of 97.5. That gives me 0.15. If we are interested in finding the percentage below 85 is 50 minus half of 68. Half of 68 is 34. So the answer is 16. If we need 130 to get a higher membership in a IQ society, and if it is less than 70 scores, then they are considered as mentally retarded. If we are trying to find the percentage of IQ membership, highly qualified people will be 50 minus 47.5, which is 2.5. The same way the other answer will be 2.5. So in this video, we talked about the normal distribution, and in fact we talked only one portion of this, which is that 68, 95, 99.7 rule application, how to calculate the probabilities using this approximation 68, 95, 99.7 rule. In my next two videos, I'll explain how to get the normal distribution using the table, normal distribution table, and also how to get the probabilities for a normal distribution using a TI calculators. Hope this video was helpful. Thank you for listening and thank you for your patience. Thank you.